Welcome students to today's lecture on noise reduction and audio cleanup. Noise reduction is the process of removing unwanted noise from an audio recording without affecting the primary content. It typically involves identifying a section of the audio that contains only noise, which serves as a noise print for the algorithm to recognize and filter out unwanted sounds from the rest of the recording. This process is commonly done in two steps. Capture the noise print. Select a portion of the recording that contains only background noise, such as hums or ambient sounds. Apply noise reduction. The software then uses this noise print to filter out similar noise across the entire file. While this technique is effective for removing steady background noise, overuse can result in unnatural audio, making it sound thin or overly processed. The key is to apply noise reduction moderately, focusing on cleaning the audio without compromising its natural quality. Audio cleanup goes beyond noise reduction. This is a different technique and focuses on improving the overall clarity and quality of the recording. This process involves removing or reducing audio imperfections such as clicks, pops, distortion, plosives, and sibilance. Cleanup also includes reducing or eliminating hiss, echoes, and clipping. The result is a polished, professional sound that enhances the listener's experience. The first widely used audio noise reduction technique was developed by Ray Dolby in 1966. Intended for professional use, Dolby Type A was an encode-decode system in which the amplitude of frequencies in 4 bands was increased during recording, encoding, then decreased proportionally during playback, decoding. In particular, when recording quiet parts of an audio signal, the frequencies above 1 kHz would be boosted. This had the effect of increasing the signal-to-noise ratio on tape up to 10 decibels, depending on the initial signal volume. When it was played back, the decoder reversed the process, in effect reducing the noise level by up to 10 decibels.
Type A is a faithful emulation of a famous vintage tape encoder from the 1960s. The original unit was designed to be a noise reduction system for tape recording. This occurred in 2 stages: the recording or encode stage and the playback or decode stage, but it was often misused as an enhancer. Type A emulates the encode stage, which dynamically increases the top end of a signal without introducing artifacts or altering the harmonic content. The results are similar to a dynamic EQ, which adds presence and air to a track in a natural way. Let's take a look at the interface. The input signal is split into 4 bands, with the highest bands overlapping. You can enable or disable each band with these buttons.
We're walking arm in arm across this land, matching freedom's cadence stride for stride. We're walking arm in arm across this land.
You can also adjust the volume of each band by going into the second page and clicking on the cog icon.
We're walking arm in arm across this land, matching freedom's cadence stride for stride. We're walking arm in arm across this land.
The signal in each band is dynamically compressed and then summed back with the direct signal. You can disable the direct signal if you want to just hear the 4-band output.
We're walking arm in arm across this land, matching freedom's cadence, stride for stride. We're walking arm in arm across this land, matching freedom's cadence, stride for stride.
The amount of compression on each band is inversely proportional to the volume of the band, which means that quieter sounds get brighter, while louder sounds remain almost unchanged. This adds brightness in air without generating any new harmonic content or distortion, resulting in a more pleasant and natural enhancer compared with a typical exciter. One of the most common mods to the original unit was a technique known by many names such as the vocal trick, the stretch mod, vocal stressor, and even the John Lennon mod. It consists of disabling the two lower bands so that only the high-frequency portion of the signal is compressed, giving even more air to the vocals.
A sacrifice seduced for the altar of your vanity. A jealous, hungry God craving praises of profanity. With bedroom dark and dined, and a deep mouth stained with wine, it drinks its fill.
So let's define types of noise in audio. Background noise, unwanted ambient sound like room tone, air conditioning, or outdoor noise. Hiss, a continuous high-frequency noise often caused by poor quality recording equipment or electrical interference. Hum. This is a low-frequency noise, usually caused by electrical equipment or power line interference, typically around 50 or 60 Hz. Now coming to clicks and pops, sharp, brief sounds resulting from digital artifacts, poor connections or physical interference with microphones.
Hello. Today we're going to remove pops or clicks from a web file that we have found that has a defect on it. So we look at the file, we isolate it, and we notice that there's something wrong with it.
Omba, omba, omba.
There's something clicking in there, something that says that the web file is corrupted in this case. So what we're going to do, we select the file, we open the file editor. Here we can see the wave. Let's hear it again.
Omba, omba.
It definitely has a defect in it, and more or less I would say it's around this area. We're going to zoom in to try and find it. And we can already see, whenever we zoom in the file, that there is a defect already here. There is something strange going on, like the wave seems to be interrupted. Let's zoom in a bit more. There we go. Here's the peak. We see there's an interruption in here. You can see it a bit better. And this peak is what's causing the defect in the sound. So what we're going to do, we're going to use the pencil tool. We press T and we're going to use the pencil tool to actually rewrite this bit. We just click and drag with the pencil tool, and this is corrected. So let's hear it again.
Omba, omba.
Sorry, let me zoom out so you can see it again.
Omba, omba, omba.
And that's it, defect on. Thanks for watching. Bye.
Plosives, loud explosive sounds caused by burst of air when pronouncing certain consonants like P or B.
Welcome to Saturday Suggestions, or whatever the hell I'm going to call this thing. I wanted to start with a very simple and very straightforward tip or trick to improve your audio quality, and this will help you reduce or remove plosives completely. If you don't know what a plosive is, that is what happens when you have a P, a P, or a B, and a burst of air hits the microphone's diaphragm. A lot of folks will have a microphone directly in front of them, pointed directly at their mouth, and this leads to the P's and the B's hitting the diaphragm of the microphone. For instance, please bring pizza pronto. You can hear that gust of air hitting the microphone. A free and easy way to avoid this is to move the microphone about 45 degrees off angle and point it at your mouth. Now, if I say, please bring pizza pronto, the air is going directly past the microphone and not hitting the diaphragm.
Sibilants, harsh, high-frequency S sounds in speech, which can become overly pronounced, especially with sensitive microphones.
Hey everybody, welcome to Serious Gear. In this episode, we're going to do a mic shootout, seeing which microphones handle sibilants better. Okay, so here we go with our shootout between the KSM-8, the AKG, and the RE20 to see which one is more sensitive to sibilants. Here we go. Sam, Sam's, snake, snuck, softly. Sam's, snake, snuck, softly. Sam has a snake. Sam has a snake. Sam's Is there a difference between the three mics? Which one did you prefer? You let me know in the comments if you thought there was a clear winner in the sibilance test of these mics.
Clipping, distortion caused when the audio signal exceeds the recording system's maximum level, leading to harsh and distorted sound.
On this recording, I sound amazing because my audio isn't clipped or distorted. But on this recording, you can hear clipping and distortion on my voice, and unless you're going for some crazy effect, it sounds terrible. You can also see the clipping on the waveform. The first recording looks great. You can see the tops of the waveforms throughout the entire recording. But on the second recording, the waveforms are hitting the top, and this is where the audio is getting distorted.
Reverb or echo. Unintended reflections of sound that create a reverberant or echo effect, often due to poor recording environments.
Echo. Delay. Reverb. Does anyone know what reverb and echo are?
You know, fool know.
Tell us, Mr. Audio. When you stand on the rim of a canyon and yell, "Hello!" Hello! And you hear your word a second or so later, that's an example of echo. Essentially, it's the sound that's reflected back to the listener. There can be multiple reflections, as sound bounces off walls, floors, ceilings, and other hard objects. When these reflections arrive very close together, the listener no longer hears a distinct echo. This then is reverb, short for reverberation. It's what people hear when they sing in the shower. At one time, studios had rooms called echo chambers, a misnomer since they actually were creating reverb. They had a speaker that played back the sound and a mic to pick up the reflections from the room. Later, springs and also metal plate reverbs were used in studios. Tape recorders were typically used to create actual echo. The studio term for this was slapback. Today, both reverb and echo can be created digitally. When used properly, they can add a live quality to the recording and help in getting a better performance.
Noise profiling is a process in digital audio editing where a specific segment of unwanted noise, such as background hum or static, is isolated and analyzed to create a profile or fingerprint of the noise. This profile is then used by noise reduction software to subtract or suppress similar noise throughout the entire audio track, thereby cleaning up the recording without affecting the desired audio, such as dialogue or music. This method is commonly used for removing consistent, repetitive noises in recording. Spectral editing is a technique used in audio processing that involves usually analyzing and manipulating the frequency spectrum of an audio signal. Unlike traditional waveform editing, which shows the amplitude of sound over time, spectral editing displays a visual representation of the audio's frequencies. This allows the editor to isolate and remove or modify specific unwanted sounds, such as clicks, coughs, or background noise, without affecting the rest of the audio. By targeting noise based on its frequency, spectral editing enables precise control over complex audio issues. Real-time noise reduction, adaptive noise reduction that adjusts based on audio. So, this is an audio processing technique that constantly monitors and reduces unwanted background noise during the recording or playback, unlike traditional methods, where noise is removed after the recording process. Real-time noise reduction adapts dynamically to changes in the noise environment, such as air conditioning hum or background chatter. This is particularly useful for live streaming, broadcasting, or situations where immediate audio clarity is required. So now let's cover audio cleanup techniques. Declicking focuses on eliminating sharp, brief noises like clicks, which may arise from electrical interference, digital artifacts, or poor equipment connections. These clicks can be distracting and disrupt the flow of audio, so there's some software tools that you can significantly improve the quality of your video if you have the segment of clipping. The popping addresses plosive sounds caused by bursts of air hitting the microphone when speaker pronounce certain consonants like P or B. This creates a sudden harsh noise. Pop filters and software tools help mitigate these effects. This is a tool that helps to work with sibilance, because as this is a sound that has harsh, high-frequency audio. So please consider using S always, because it will improve, yes, the quality in general, but especially if you have people who has problems or some special, yes, way of telling S. This sibilant sound can be overly pronounced and because of that annoying, especially when recorded with sensitive microphones, making the audio uncomfortable to listen. Declipping, an audio restoration process used to repair audio that has been distorted due to clipping. Clipping occurs when the audio signal exceeds the maximum allowable level of an audio system, causing distortion and harshness in the sound. This can happen when recording levels are set too high, resulting in a clipped waveform. The clipping algorithms analyze the waveform and attempt to reconstruct the lost peaks and valleys that were cut off during the clipping process. This helps to reduce distortion and restore some of the audio natural dynamic range. So for wrap up, just please pay attention to this slide. We have declicking, depopping, declipping, for example, the S series. So there's plenty of software tools, some of them free, like in Adobe Premiere, some of the paid, so that's why they allow you advanced control over all of these features. So best practices for noise reduction and audio cleanup. Avoid overprocessing. Be careful not to apply too many noise reduction effects at once. Overprocessing can lead to the audio sounds unnatural and distorted. Focus on subtle adjustments to preserve the original quality of the sound. The key here is not to use a lot, but several, and each of these several you can adjust little by little. Use multiple passes. Instead of trying to fix everything at once, break down the cleanup process into stages. For example, start with noise reduction, then tackle hums, clicks, or other specific issues separately. This ensures better control over the final output. Prioritize getting a clean recording. This is really important. You should fight for the quality of the sound at the location of your recording. So it means proper installment of the mic, yes, Prevention is better than cure. It's essential to minimize noise at the recording stage itself by using good recording techniques, equipment such as microphone placement, soundproofing, and using quality gear. Balance between cleanup and sound integrity. Don't sacrifice audio quality for noise reduction. So please be careful. This is your priority to care about the quality of your final product already during shooting production stage. So in conclusion, noise reduction and audio cleanup are fundamental skills for any podcast producer or audio editor. The key is applying these techniques carefully to enhance clarity without distorting the natural audio. Always focus on capturing the best possible recording first. Then use noise reduction tools as needed. Thank you so much for attention. See you in the next part.